All right, happy last day of March. Okay, now on the sides, if you have your graphic organizers handy, they may be helpful when you're doing these problems. Okay, so a big thing is like, how do you evaluate definite integrals? And remember, the key is to look at the integrand and figure out what you know about the integrand. Okay, so for this one, you have a graph of the integrand. So you know you're going to use area. Okay, so let's see. So we're starting at 5. We're going to 13. We're integrating forward. Careful that you don't just pick up the x numbers here. So this is going from 5 to 11. So this is 6 by 3. That's 18. Half of that is 9. And this is 2 by 1. So half of that multiplied is 1. Okay, so we're going to add the areas. And since we're integrating forwards, I have to subtract 9 and add 1, which gives me -8. Okay, now for the second one, what do we know about the integrand? Well, they told us about f prime, and so we know about the antiderivative. We know that the antiderivative for f double prime is f prime, and we have the graph, which means we can use the fundamental theorem and just look at the graph for our output. So this is f prime of 13 minus f prime of 5. And on the graph at 13, that's a height of 1. And at 5, that's a height of -3. So 1 minus -3 is 4. Okay, so we're still looking at the same graph. And we want to know when f has a relative maximum. So this is not the graph of f because that would be a 2 algebra problem. So what are we looking for? Sometimes I like to write the reason first. F has a relative maximum when f prime changes from positive to negative. And if I look at my graph, that goes negative to positive. I think it's just at x equals 4. Okay, one more. So it's really the same questions as we did first semester, except now we need to know the second fundamental theorem. No adjustments needed. So h prime of x is just the integrand evaluated at x. So it's f prime of x. We have the graph of it. Okay, if you're looking at your handy dandy green sheet that everybody loved, an inflection point happens when the derivative changes from increasing to decreasing or vice versa. So I'm going to write that first. H prime changes from increasing to decreasing. On the real test, write the words out, or vice versa. And so let's look at our graph and let's see where that's. So we're increasing, whoop. So there's 1, and decreasing and increasing. So I think we got at x equals 3 or x equals 5. Yes.